Welcome to this session. In this session, we are going to discuss about the Laplace transforms of derivatives of functions and integrals of functions. So let's see how that one is. So the Laplace transform of derivatives and integrals. So let f of t be a function of t, and f prime, f double prime, f triple prime be the first, second, third, up to nth derivative of this function f of t. Then the Laplace of f of t, then let the Laplace transform of f of t be capital F of s. We have that Laplace transform, so this one, of f prime of t, that the first derivative is s times capital F of s minus f at 0. So note that this capital F and this small f, and then 2 Laplace transform of second derivative of f with respect to time is given by s squared capital F of s minus s f of 0 minus f prime at 0, where f at 0 and f prime at 0 are the initial values of the first derivative and second derivative, first derivative, initial values of the function and its first derivative. Then the general Laplace transform of the nth derivative of the function f of t is given by s power n capital F of s minus s power n minus 1, capital F, small, the function at 0, or the initial value of the function, minus s power n minus 2, first derivative of the function at 0, minus several terms up to minus the nth minus 1 derivative of the function at 0. So that's this, we can call it formula 3. This is the general formula for finding the Laplace transform of an nth derivative of function f of t. Now, we also have number 4, the Laplace transform of a function, or integral from 0 to t of a function f of t dt is given by 1 over s times capital F of s. So if you know the integral, if you know the Laplace transform of a function f of t, then you can always define the Laplace transform of the integral from 0 to t of that function f of t. So an example, so the Laplace transform of a function x of t is capital X of s, given that value of the function at 0 is 2 and derivative of the function at 0 is -1, write the expressions for the Laplace transform to second derivative minus 3 first derivative plus x, and then b minus second derivative of x plus 2 first derivative of x plus x itself. So remember, this is 2. Now, so what you're going to do, you're going to find the Laplace transform of these derivatives and then replace into the function and see the result. So our solution, by definition, we know that the Laplace transform of first derivative of x would be given by s capital X of s minus x at 0, which will be given by s times capital X of s minus 2, because already x at 0 is 2. And Laplace transform of second derivative of the function x, remember this is a function of t, is given by s squared capital X of s minus s x of 0 minus x prime at 0. And so when you replace this, we get s squared capital X of s minus 2s plus 1. So now once we know the Laplace transform of every part, then it'll be easier now to find the Laplace transform of this expression. So A, Laplace transform of 2 second derivative minus 3 first derivative plus x will be Laplace transform of twice second derivative plus Laplace transform minus 3 first derivative plus Laplace transform of x. Just applying the linearity property of Laplace transform. Now, this is the same thing as twice Laplace transform of the first or the second derivative minus 3 Laplace transform of the first derivative plus Laplace transform of x. Now we have the value for Laplace transform of the second derivative of the function. So this one will have 2 into the place of this we replace by s squared capital X of s minus 2s plus 1 minus 3. The place of Laplace transform of x prime is s times capital X of s minus 2. Now the place of Laplace transform of x by definition is capital X of s. So then let's open and simplify. So I'll have 2s squared capital X of s minus 4s plus 2 minus 3s capital X of s plus 6 plus x of s. Now we collect like terms, so those terms with capital X. So I'll have 2s squared minus 3s plus this coefficient is 1 capital X of s and then minus 4s and then 2 plus 6 is 8. So therefore this will be the answer to the first part. And then B, at B, we have to find the Laplace transform of minus x double prime plus 2x prime plus x. So this by linearity property of Laplace transform will be Laplace transform of negative x double prime plus Laplace transform of 2x prime plus Laplace transform of x. Further linearity property, this gives negative L of x double prime plus 2 Laplace transform of x prime plus Laplace transform of x. So which will give us negative. Now the place of Laplace transform of the second derivative, we have already defined the answer to be s squared capital X of s minus 2s plus 1 plus twice Laplace transform of the first derivative of x. We have gotten the answer to be x of s minus 2 and then plus Laplace transform of x from definition is capital X of s. So which will give us negative s squared capital X of s plus 2s minus 1, and then plus 2s capital X of s minus 4, and then plus capital X of s. Now we are going to collect terms with capital X of s. So negative s squared plus 2s. Coefficient of this one is 1. And then capital X of s plus now 2s minus 1 minus 4 is minus 5. So this will be the final solution for that given problem. Thank you.